Thank you very much. This is working. Awesome. Yeah, it's a great honor to be here. I first want to thank the organizers for organizing such an amazing event. I really learned a lot already, and I hope you will enjoy my talk, which is about from database dumps to streaming. So, this should actually work, but of course it does not. Yes. So, the year was 2012, and I was studying at a university here nearby information systems. And when I needed money to finish the studies, I joined a mobile gaming company here next door in a Backfabrik. It's a red building here in Prenzlauer Berg. As a data engineer, as a working student, basically. And just before that, the company had picked up Kafka from this famous Berlin Buzzwords conference that you heard about before. It was a new streaming technology, and I was really excited to work with it. So I joined VUGA full-time after finishing my thesis, even though at my university, one of my professors and organizers talked about a very nice project called Stratosphere that was happening and co-joined with the TU Berlin. But I was like, well, it doesn't sound so practical at that moment. Maybe now I think different about it, because later the Stratosphere project became Apache Flink. But yeah, back then I wanted to do something practical, I thought. So I faced a lot of issues with Kafka back then, because there was no thinking about event time. We had lots of mobile games that were played. We had devices that were going offline at some time, and then they went online again, and then we said, okay, we're going to just say, when the event arrives in our system, we're going to say, this is a timestamp. So we're going to stamp it with an event TS, but only when it arrives in our system. So after moving to a couple of different jobs, I moved to a job where I had to work with the Dataflow SDK. I especially picked that job because of the Dataflow SDK. After reading the famous blog post by Tyler Kidau, Streaming 101 and Streaming 102, and those were really eye-openers, because when I read them, they are examples based on a mobile game, actually. I said, oh, I know these issues. I had all these issues. They sound really familiar to me. That's really something I experienced firsthand in my working life. So it was apparent to me that this SDK was solving a lot of streaming problems, even though we were using it only in batch mode back then. But I was like, hey, this seems to be the right path going forward. Therefore, I was very excited to see that it was open sourced in 2016 and became Apache Beam. And in 2018, I then joined the data intelligence team at Ricardo.ch, and things looked a bit different at first, because Ricardo was founded in 1999, which was yeah, kind of the time before I actually started my career. So maybe I can get a short show of hands. Who is working at a company that is older than 5 years? And who is working at a company that is older than 15 years? And who is working at a company that is older than 20 years? Okay, so those people, yeah. But you know, okay, so you see that legacy becomes a different kind of meaning when you work in these kind of environments. But there was a decision that was made by the CTO and all the teams that they said, hey, we want to get rid of the data centers, we want to move to the cloud, we want to be more flexible, because we had 2 data centers, we reduced it to 1 data center, and then we also want to introduce streaming to the teams. And so in 2017, there was the move to Kafka, and Ricardo looks a bit like this right now. So if you go to the website, there's also a mobile app, of course, but basically the business is you have auctions and you have fixed price stuff, and people sell their used items or their mostly new items. So basically it gives secondhand a new home, and it's based in Switzerland with over 3 million users, which makes it the biggest marketplace there. To give you kind of an idea what we're dealing with here. And this is why also 1999 it was founded, because back then auctioning was the first thing that came up as an idea to do in an online world, or one of the first ideas. So we needed a plan in the DI team that I joined, because we wanted to move things around. We want to go from on-premise batch to on-premise streaming to cloud streaming. And the main problem here that we faced was the constraint of limited processing power, because it was clear to us that there will be no new machines bought. So it was like, okay, this is what you have, now work with it. It was clear that we had a Kubernetes cluster on the stage, and we also had a Kafka server inside the data center, but we needed a plan first to get rid of basically our database, because the database that we had on-premise was also a SQL server, like with Vente Privé, who presented before me. We wanted to move to BigQuery, so we needed a plan to actually get there. And the plan that we came up first was, yeah, we're just going to dump all tables in the fastest way possible to JSON, and that actually was done in a very fast way and efficient way, because we did some random load tests, and the BCP utility provided by Microsoft is actually the fastest way. It stands for bulk copy, to dump a table into a new line delimited JSON. We had to upgrade the server to version 2016, I guess, so that it was possible, but this really enabled us to do it very fast. And instead of using an off-shelf market tool, we really used just this BCP utility to dump the stuff, and then pushed it to a Google Cloud Storage bucket, and then loaded it constantly into BigQuery via Airflow, which is like a scheduler system, or cron on steroids, you could say. It was mentioned a couple of times. Just if you don't know it, it's like cron, but with more sugar. Yeah, if you look at this and you think, hey, I'm at a Beam conference, why is he talking about this kind of stuff? And you're like, why not Beam? Like, this is a perfect use case, because you have like files pushed into Google Cloud Storage bucket, and Guido von Rossum is looking at you, like the inventor of Python here, and says like, why? Like, why are you not doing it with Beam? And I was probably wrong, but I joined this company as a very new team member, and I didn't want to push too much technology and say like, hey, let's do it with this. And also, I didn't have experience with an on-premise runner, so I thought maybe I cannot run it on-premise inside the data center. And I thought, oh, if I run it in the cloud, then maybe this will cause unnecessary costs added to our team bill. And then I said, okay, just gonna do it in Python, because then I have complete control over how much code is being run. Obviously, if you're watching this, or if you're watching this on YouTube, there's a better method. You can just use file match continuously on a GCS bucket in the streaming pipeline, and then this will actually take care of for you of the rest. So the situation before the move was we had Kafka inside the data center, we had Kubernetes inside the data center, as I told you before, and we had limited SRE time available. So this is really important, because I had to kind of pull it off as a one-man show, so I needed a system that is really reliable and something that didn't wake me up all the time at night. So the first step was, as I said, we already had Kafka in the teams, but most teams were using Kafka just to transfer state. So they said, an order has been created, okay, here's a stream of new order IDs that have been created, and now you go and fetch the metadata. This is possible in Beam, as we know, but the problem was that it would have been additional development, and I had many teams to follow, and they had many engineers, but I was only one person, so I said, well, we have to agree on a format. So it was already clear that protobuf is being passed around, but a state machine doesn't really fit our use case here, so we need the full record. So what we agreed on is basically, or what I told everyone was basically, hey, we're going to pass envelopes around. An envelope has an event.ts, that's the timestamp that is stamped on the envelope, and it has a UUID, that's the UUID of the message, so of the envelope that is being passed around, and then you put your information inside this envelope. And I also called this envelope in the object of protobuf so that everybody understood, okay, this is the outside layer of this message so that the messaging works. And inside they could put their stuff like order ID, order creation, timestamp, and so on. But this concept of telling people it's an envelope was really helping to get the message across why we need an event.ts and what's the difference between processing time and event time, because you could make the example with when the envelope arrives and you unwrap the envelope and so on. So it cleared. This was the example actually that I tried many examples. This was the example that worked when trying to get the situation across. By the way, this is Kelsey Hightower. That was very happy that we finally got the message across. So then we had to choose a runner, and I have to say thank you to a lot of people today, especially to the Beam Slack channel, to the mailing list, to the people that I bothered there, especially to Maximilian Michels, who's somewhere here around in the audience, because I had a lot of talks with him on the previous Beam Summit about our Apache Flink deployment on Kubernetes. Yeah, the thing is that everything that you need to get started actually is provided by the Apache Flink team. So also thank you to Fabian Hüske and his team, who's around here somewhere, for providing this starting files for a job cluster deployment. And yeah, I was able to build everything together, and it really worked solid, you could say. I linked the deployment files, or the link to the deployment files is in the slide notes that I will share later, but that was super helpful. Enough of pictures, so now another picture. So basically this is the very simple representation of the pipeline. You can see that we were using file loads in the bottom of this slide. We had a refresh frequency because, again, we were kind of cost sensitive, so we said we're not going to go streaming first, but we will go do file loads, which actually makes the BigQuery I/O load files into BigQuery, which doesn't incur any additional costs. So when you use streaming, you pay around $50 per terabyte, if I'm not mistaken. Please correct me if I'm wrong. But if you use file loads, it's actually free. And the other good thing is basically when you use streaming, then you can only stream back to 7 days or something. So you have to make sure with a switch that you don't push in data that is older than 7 days. But we were in a phase where we regularly had to restart pipelines and we regularly had to fix stuff. So we said, okay, this is a rock-solid implementation where it will just work. It will mean that you have a refresh frequency around 5 to 10 minutes, which actually is here in the middle, because there's a limit in the BigQuery API that actually allows you not to go down further, because then you're exceeding your quota. But this was actually the very good thing that worked for us. And also another tuning thing that I applied was a recreate instead of rolling update on Kubernetes, meaning that as you have checkpoints on Flink, if you want to roll out a new version of the pipeline, I simply updated the Docker image, and then I rolled it out to Kubernetes. And instead of saying like, hey, I'm going to wait, 25% of nodes needs to be available and so on, I just killed all task managers at once. Since the job manager was still there, as soon as the task managers came back online, they continued their work. And only for the pipelines where I had an updated protobuf or where something has changed, I needed to drain them before. So I drained them, and the other ones were just shortly shut on again. So this was really allowing us to deploy very fast. If you're interested in these kind of tuning things and you're also interested in running on Kubernetes with Flink, I'm happy to talk afterwards to go more into details. The most important tuning aspect, which will be discussed in detail now, is fast storage for checkpoints. So Flink is heavily relying on checkpoints to make sure that your pipeline is fail-safe. And usually in the examples online you find, you use S3 or you use Google Cloud Storage. But what does it mean? I mean, what are the pros and cons of these approaches? So I tried all three that are listed here, and I give you a little bit of input on this one. So cloud storage basically works like S3. You have an object store. You pay per 15,000 or 10,000 requests, and you pay per volume that you're storing. Snapshots are not really huge, so you can say that the volume is not really the cost driver here. But if your pipelines increase, and our pipelines are right now at 27, so 27 pipelines, then the requests, if you have a low snapshot time, every 30 seconds, for example, they make up a portion of the bill. So they really become visible. Actually, much more visible than you thought in the beginning. The performance obviously is okay because you have this request going back and forth. But I thought maybe we can do better. And there are persistent disks in Kubernetes, and there are now also zonal persistent disks that are replicated across 2 zones. So I used one of those, and I used NFS read-write many volume provider as a pod in Kubernetes to make this available as a NFS share. I linked it also in the notes if you're interested in this. Actually, this provides you higher performance, and if you have a GKE or a Kubernetes cluster that is just doing Flink, you're fine. This performance is awesome, it's super nice. But when we move to production and into our production cluster where we share the cluster with other teams, the latency went up again. And I was like, okay, so if there's not more network traffic inside the cluster, it seems to me that it's not as performant as I would like it to be. So the third option here is Cloud Filestore, which is a new service launched 3 to 5 months ago. It's basically NFS as a service. You have to take at least 1 terabyte, which is a lot for Flink, but you can also you can slice it in Kubernetes and give something else to somebody else who needs it. And you pay per volume, so it's about $230 or something per month. But here you can see that the performance of the last checkpoint duration, this is the mean checkpoint duration across all 27 pipelines. When we switched from this middle option, so from this persistent disk option where the traffic was increasing the snapshots, to the Cloud Filestore for the checkpoints went down to under 200 milliseconds. And this is really giving you the, very good feeling that you say, okay, we are confident that if something happens and Kubernetes is fast in spinning up the task manager again, you will be back in seconds, and you can guarantee that fraud detection will deliver. So after the move, we had the following situation. We had a managed Kafka that was peering to our Google Cloud project. So that was outside, but it was reachable. We had managed Kubernetes before I had to set up the Kubernetes cluster on my own, and we had Flink in our own cluster. So now I just needed to care about to manage the Flink cluster. And now we also have more SRE support because the move is done, and we share responsibilities. For example, we share the Zookeeper instances between Solar and Flink because then more eyes are looking on Zookeeper, which actually is a good thing because more people will actually jump on it if there is a problem. So next steps. Yeah, as you saw, it's a pretty basic thing, but for the last 12 months, for us, it was quite an achievement to go from a data center that we actually shut down successfully in March without any hiccup to a cloud-based streaming solution, from a SQL Server database to BigQuery without any major hiccups in the reporting. So that was quite an achievement, and for us there are great things ahead. So we will work on getting the search engine loaded via Beam as the same way, approximately the same way as Vente Privé does. So we don't use Elasticsearch, but we use Solar. So we're happy that the Solar connector is in. We're going to have fraud detection on streams instead of tables. So basically, we know that streams and tables are kind of the same thing now, as we were told yesterday. Or basically, a stream is a table in motion. But the thing is, basically, we want to be faster with the fraud detection. So that will be a project we will be working on. And we are super happy and super stoked for the streaming SQL and for the developments that are happening right now for Beam, because I see tons of applications for our analysts and data scientists. So that makes us really happy. And Jesse Frizzell, the software engineer, best known for her work on container systems as well. And with that, I want to say thank you, and I'm happy to take any questions. Thank you.
Thank you so much. We are going to open the floor for questions. Please raise your hand if you have a question. One last chance. Oh, there we go. Fantastic.
Did you consider using Dataflow from Google for that?
Yeah, sorry. That didn't make it in the slides because it was 20 minutes limit. So yes, the final plan would have been, in the beginning, the final plan was that we said, okay, we're going to have, when we were here in this planning phase, we said we're going to have this in the end, right? So we want to go cloud streaming. We want to have no management of that. to be honest, Flink has certain things that you don't get with Dataflow. And as I said, we're kind of cost sensitive. So basically, we have, for example, 4 very small Kafka topics. And with Flink, I can say I'm going to provision a task manager with 10 slots on a 5 CPU node, even though usually the slot to CPU should be 1-to-1, right? So I kind of over-provision, or basically I'm under-provisioning the task manager, but I'm overutilizing the machine. This enables you to save money because you don't need to spin up a streaming Dataflow machine for 1 topic or 2 topics. And it gives you great flexibility in the way of saying, hey, this is low traffic topics, we're going to squeeze a little bit more, and these are high traffic topics, we're going to push a little bit more there. And I did the back of the envelope calculation. If you ask me if you would start, and for our engineers, when they start, I'm always saying like, hey, if it brings money, if it's a feature, go for Dataflow, absolutely. But as we were in a different situation of moving legacy to a new system, keeping the cost neutral or keeping the cost actually lower to have a selling point was a big issue. So looking back, if you would ask me, the last step would have been to say, hey, now Dataflow, but for now we're super happy with the solution. But for new projects, we will definitely consider this. Thanks for the question.
All right, thank you. Any other questions? Okay, don't be shy. One last chance. All right, thank you so much for your presentation.